Okay, so based on the step 1, the terms we mentioned before for computing the individual relations, the size, the plan, as well as the cost for step 1, and we can further go upward, right, to the step 2 to step 3 until step n, right. In this page, we show you a general step is step I, and in this step, we also want to calculate the 3 terms we mentioned before for the subqueries. So for step I, for each subquery, Q, which is a subset, which covers the joins of the subset from the relations R1 to Rn, and we want to do these following steps as well for computing these 3 terms we mentioned before. The first one is the size, right? We have to calculate the size for Q again. As to how to define a size for Q, we will introduce it later for you instead. So you can see we still have to compute the size for Q as well when we go to step I. And besides the size, another two terms we will have to compute is the plan as well as the cost, right? So the plan denotes the corresponding plan for the queries. As to how to decide the plan, it depends on the cost actually. So the plan we achieve in this step will correspond to the one with lowest cost actually. As to how to achieve the lowest cost, we will have to find the best way to combine the subset of the relations. So in other words, in this step, for every pair of subqueries Q prime as well as Q prime prime, we want to ensure that the relation covered by these two will be equal to, if we join them together, will be equal to the Q, right? In other words, we enumerate all the potential combinations of subquery or subrelations which can compose this Q query, right? And we want to enumerate all these kinds of pairs. And we can compute the cost for the plan of Q prime as well as Q prime prime, right, by joining them together. So you can see, for this Q, it will be a combination of all the potential subqueries which can compose this query, right, this Q. As to a cost measure, it will be corresponding to the optimal or the best combination of the Q prime as well as Q prime prime. And the smallest cost will be, we achieve from this step will be defined as cost for Q here. You can follow me, right? So, to compute the cost for Q, we have to enumerate all the potential combinations which can define or can compose this Q, right? And the one which can lead us to the smallest cost will be equal to the cost for the Q plan, right? At the same time, we can also define the plan for the Q to be the one to be the logic tree or the join trees defined by the combination we show here, right? Which can lead to the smallest cost. And we can define this plan Q to be the corresponding plan we achieve from this step. And so you can see in the step I, we can achieve the size of Q, the cost of Q, as well as the plan of Q according to the method we show here, right? We have to enumerate all the potential combination of Q prime and Q prime prime, which can lead to the lowest cost. And this step will continue until we can achieve go to the final result for Q equals to R1 until Rn, right? And we can return the final plan and the final result. Okay, so this is the dynamic programming based algorithm for computing the computing the optimal joins among these relations. So we have introduced step 1 already for you, and then we can introduce step I. And this step I, this I will be equal to 2 until n, right? When is I equals to n, we can return the final result for the plan Q, right, and the final result for the joins. Okay, so this is a dynamic programming based algorithm. And here we also mentioned that we have to define size Q later, right, which we will be showing in the following pages.